Okay, so continuing on from where we left off, we've basically got currently our jump group, right, with this very fastly expanding torus, right? At the moment the torus is expanding a little bit too fast, so I'm going to adjust the expression that is being used to scale up, or rather influence the radius of the torus, yeah? And I'm just going to make it 10 times smaller. Yeah? So it starts at 0.1 and it just starts growing like this. Yeah? So that's better. That's more what we need. Okay. From this point on, I'm going to start jumping into the particles. Yeah? So let's lay down a pop network, and feed in the geometry into the first context so that we can start using it. And let's jump inside. First of all, we need something to birth our particles from. So let's lay down a source. Yeah? And for the source, I'm going to use the first context geometry. Right? If I start playing, you see the particles are being born, yeah, and they inherit the attributes of the points. But in this case, I mean, I don't really, what I want basically is, I want to emit the amount of particles all at the same time. How many? Well, the amount of particles that there are points. So I need to make sure, yeah, that I emit, 400 points. I know that this is 400 points because basically if I middle mouse button over there, it says 400 points, yeah, on the jump group, 400 points. And let's just go in there, right? So what do I have? I've got my impulse activation and I've got my constant activation. At the moment, constant activation is turned on, which means it's gonna emit 100 particles per second. Yeah? And what I want is just once emit 400 particles. So I'm going to turn off my constant activation and I'm gonna turn on my impulse birth rate. So as you can see, immediately all the points have been used to emit particles from 400 points, 400 particles. So if I middle mouse button on this, I can see there 400 points. So, but the problem is, at the moment you can kind of see that the point numbers are exactly the same. They're there by default. Yeah. So because I didn't change any of this, it's very important to leave the emission type at points ordered, because this order, this number of the particle will correspond to the number of the box, of the point that the box is copied to. So the boxes that jump up later, are kind of copied onto these point numbers. So you kind of want to keep that order. Right? Okay, so in order to have them emit only once at the very first frame and then no more, because if I start going forward, you can see more and more particles are being emitted, and each frame 400 particles are being added. So I don't want that. I just want at frame 1 I want to emit particles. So what I really need is a sort of a if statement, or a result of an if statement. So I can say $frame. So if my current frame, or my current floating frame, is equal to 1, then it's going to return 1. So then it's good. But if that's not equal to 1, 2, then it's not going to emit any more particles. So at frame 1, bam, emit 400 particles, and that's it. Alright, so the next thing that I want to start doing is I want to start grouping my particles. So I need to know which particles are currently being selected by my jump group. So in order to do that, well, I'm going to break it down in 2 steps. It could be done in 1 step, in one grouping step, but I'm going to lay down an attribute. Create an attribute, just so it's gonna be a little bit more straightforward. And the name of this attribute is going to be in group, mi, or in group. And I'm going to change it into an integer, right? And I'm going to use an expression again. So back into textport. The expression that I want to use in this case is going to be hasPoint. So if I just type xhelp again, you can find it. hasPoint, this guy. So if I type that one, xhelp hasPoint, this will allow me to basically see if a point, or in this case a particle, is part of a certain group. So this function can be used to determine whether a given point is a member of a given group. So what I'm going to do is I'm going to get my jump group, of which SOP? Well, that's going to be in the SOP level, so at the moment I'm in a different context, I'm in POP level, so I'm going to have to go up to SOP, find the right one, and then I'm going to say, okay, which point? Well, that's going to be a local variable, which is $PT, right? Okay. And it's going to return 1 if the point is inside and 0 if it's not inside, right? So I'm going to start typing has point. Okay. First thing was the group name. Now, I remember my group was jump group, yeah, but if you forgot, then you can just go up again, yeah, and just go look for them, so you can see 4 points currently in jump group. Yeah. Another thing which might be a good idea now, since we're starting to, reference different nodes in between contexts, is to add a little null in between these two, just so we, kind of can reference this easier. It's kind of good practice to do that. And I'm going to name this one 2pops. Yeah? So I know this one, this node, this null, is gonna go to particle operators. It's always going to be the input. And whenever I need to change something, I can just input it in between that, those two nodes. Okay, so I'm going to be referencing this guy, 2pops, and it has my group on it, and it's got my jump group on it. So let's go back inside and let's start defining our attribute. So first of all, the group was jump group. The SOP in particular was called 2pops. I just made it. Yeah? So what I do know is that it's a level up. Yeah. So now I'm in the pops level, and it's another level up, and now I'm in the SOPs level. Yeah. And the one that I want is called 2pops. There. And the point number, like I said, was going to be a local variable, which is the number of the particles, so it's $PT. Right. And now I can see this attribute, right? If I wanted to see it, I can just bring up a spreadsheet. I'm going to go and rewind my particles first and then play for a little bit, and let's stop it there. And let's have a look. Yeah. Some of these values, where is my currently newly created attribute? There we go. In group, some of these values should not be 0. See, there we go. These guys, the ones that are 1, are currently being inside of my group. Yeah, they're currently being in the group. Okay. Now, I'm going to use this attribute to group, to make new groups, but new groups on a pop level. Yeah, so let's type group. There we go. And the idea is basically that all the particles that are currently inside of the group need to go up by a certain force. Yeah? So first things first, and I'm going to say, okay, my group, let's call this one up group. Yeah? So the particles that need to go up. Again, reference that guy. Now at the moment, yeah, I can start referencing this variable, yeah, by saying this name of this guy is in group, so I can use that one to query as a rule. Yeah? And I can say $in group like this, and I need to enable it. And again, rewind my particles, and let's check for a second. So over there I can see 84 points in up group. Yeah? So that's what I need. That's good. So let's add a force to this, and let's drive them up. Yeah? Okay, so the kind of force I need is an upwards force, so something like this. Well, let's make it a bit stronger, something like 5, so we can kind of have a look. Probably is going to be needing more. Obviously all the particles are going up, so let's put in our source group, which is up group. So only the particles that are being currently selected by the torus will start to go up. Now, problem is, what goes up must come down again, so we need to get them down somehow, right? So one of the ways to do that is by adding. You could say, well, let's add another force. Yeah. So let's add another force, and let's start taking them down. So in this case, what I need is, let's put in gravity. It doesn't need to be gravity, it could be anything really. Yeah. Now if I start playing it now, all the particles will basically start falling through the floor because they're all being affected, and some of them are being less affected because they're also being affected by the torus. So that's not exactly what I need. I need a certain way to only apply this gravity force to the particles that you know, go up or have ever been going up. So I can't really use up group, yeah, because the problem is then only the particles, yeah, that are in up group will be affected by gravity. I mean, nothing is slowing them down at the moment because there's no drag, so we'll put in some drag. But so what I really want to do is I want to create a new group. Yeah, so let's rename this quickly. So force down, sorry, up, and force down. Yeah. What I need to do is I need to create a new group. So just start typing group again. It's basically going to be exactly the same group as that guy. Yeah. So I could say, again, same thing. I'm going to call this one down group, down GRP. This one is going to be $OS. And this one $in group in GRP. Right? I need to enable this. Yeah. Okay, same thing. The only difference, yeah, is this little toggle over there, which is called preserve group. What that will do is that will make sure that the grouping occurs on every particle that is currently selected or that has ever been selected. So basically what that means is, at the moment, say there's like, in the beginning there's only a few particles in there, yeah? So you can kind of see. So what that basically means in terms of going up or down, this will select every particle that has ever gone up or is currently going up. Yeah? So the particles that are going up or have ever gone up, they are going to become affected by a downwards force. So this preserve group is very important, so don't forget to check it, yeah? In your down group. So the down force then will be using not the up group but the down group. So let's get rid of this up group and let's put in the down group. Yeah? Okay, so let's have a look. Alright, particles start falling, yeah? Straight away. Why is that? Because the down force is a lot stronger than the up force. So I'm going to give the up force, say something like 30. Yeah? So that'll make them jump quite high, but immediately they're also being affected. Yeah? So you can kind of see they're being affected by the gravity. Maybe it's a bit too high, so let's change this to 20. Right, so they're going up and they're going back down. Okay, but they're still falling through the floor. So I want to make them collide. Yeah, I want to make them collide with the grid, the same grid that they're being emitted from. So in order to do that, I'm going to lay down a collision, like this. And I'm going to say the geometry of this one is the same one as the burst geometry, so the same context, first context. Right? And I need to change some stuff, yeah, in the behavior. Instead of dying, yeah, I don't want my particles to start disappearing. Yeah, I want them to stop. So just stop on collision. There we go. And now they basically nicely land again on the grid. Yeah? So this is the kind of motion that I'm looking for. This kind of nice pattern. All right. Okay. So this is good. The next step will involve a little bit of maths, in the sense that we want to calculate the highest position. So the particles will start to go up. We will calculate this highest position that they've reached, and then over the highest position back down to 0, there's going to be a linear interpolation which will drive the rotation of the particles. So what that all means is that basically they're going up, and once they're up, they're going to start down again, and as they're going down, they're gonna make a certain degree, a certain rotation. Okay. So what I need to do is I need to add a new attribute, and in this attribute I'm going to calculate my values. So I'm going to name this value, this attribute, sorry, I'm going to name this high pos, yeah, highest Y position. That's what it means to me. I mean, you can name it anything as long as it makes sense. The type that I'm going to be using is a vector, right? Because I'm not really going to use the vector in the typical way of saying, okay, X, Y, Z position, but I'm going to use them to, influence each other's values. Alright. Let's rewind this. And I'm going to pause it again for a second.